Hey there, we're now looking at example 17 where we're going to be solving this problem, and this is a typical year 12 question where you're trying to embed quadratic equations into the problem. So here we go, this is how we do it. To do this problem, the x is an exponential, so here I've got 3 to the power of x. Notice this is a different base. I'm going to change that 9 into 3 squared, which is all to the power of x. And this is now equal to 12 times 3 to the power of x minus 27. What's interesting here is you need to also understand that when you multiply these two powers 2 times x, right, it would be 3 to the power of 2x, right? But what you can also do is, since it's timesing, you know that 2 times x or x times 2 should still be the same. So another way of writing this equation is you can write it as 3 to the power of x all squared. True? Have a think about it. Because if I did x times 2 or 2 times x, the power's still the same, isn't it? Now the reason why I want to write it like this is because notice that I have 3 to the power of x over here as well. This is 3 to the power of x, and this is 3 to the power of x. So by writing it like that, I can now say something like, make a random variable. So say a equal to 3 to the power of x. Suddenly, if you substitute 3 to the power of x with the letter a, this now becomes a all squared, true, is equal to 12 times a minus 27. So another way of looking at it is a squared is equal to 12a minus 27, and you can subtract them all into one side, so a squared minus 12a plus 27 is equal to 0 on the right hand side. And then now you can factorize using quadratics, what you've learnt in quadratics, so a, and say 9 and 3, so negative 9, negative 3, and so therefore a is equal to 3 or 9. Okay, now why is this special? Because you are now able to solve for a, but remember, what was a again? We said let a equal to 3 to the power of x. So that means I have the scenario where a could equal to 3, or a could equal to 9, and again, a is 3 to the power of x. So now you can see, solving by comparison, we can see that therefore x is equal to 1, so that's one possibility. Or over here you can write 9 as 3 squared, and this is solving by comparison. Then we can say x is equal to 2. Okay, so that's how you would solve that type of problem. Let's do it again. Let's do b. Same thing again. I'm going to rearrange this 3 to the power of 2x to become 3 to the power of x all squared, okay, because that's essentially what it means. Equals to, or it's the same thing, 27 minus 6 times 3 to the power of x, and again I can say let the letter a equal to 3 to the power of x, and why do I do that? Because it changes the problem to become a squared is equal to 27 minus 6 times a. And then if you rearrange it, you get a squared plus 6a, so adding 6a's on both sides, minus 27 on both sides. That's equal to 0 on the right-hand side. And again, you can factorize this now. And that gives you a, and what's this? Maybe 9 and 3 again. So positive 9 minus 3. And so therefore, a is equal to, using null factor law, is either 3 or negative 9. And then from here, remember, since a is 3 to the power of x, if it's meant to equal to 3, or it could also be 3 to the power of x is meant to equal to negative 9. What we know here, this is undefined. You can't ever solve 3 to the power of x to equal to negative 9, because if you think about the graph, try typing in your calculator now, 3 to the power of x looks like this. It has an asymptote at y equals to 0. So you can already see that the graph, the y value is always greater than 0. So it's impossible to think of what power will give you a negative value. You won't. No matter what x value you choose, it's always going to be above 0. It's definitely going to be negative 9. You don't have the point on the graph where it's in the negative 9 region. So that's why we know this is undefined, okay? And then over here, solving by comparison, we can then say, therefore, x must equal to 1. Okay, so that's how you would solve example 17 for part A and part B. This is a typical exam question year 12. Back in probably a decade ago, they probably have moved on to logarithm.